This is Geometry Unit 8, Lesson 6 on midpoints and parallel lines. We're going to be looking at midpoints and parallel lines. The first thing we're going to look at is the mid-segment theorem. We talked about mid-segments a few units ago when we were talking about parallel lines. So let's revisit it and prove what is true about a mid-segment. The mid-segment theorem says if a segment joins the midpoints of two sides of a triangle, so here's a midpoint, creating a mid-segment, then it is parallel to and half the length of the third side of the triangle. So what we're going to prove is that if MN is a mid-segment, we are going to prove that the length of MN is half of the length of AB, that's the side it's parallel to, and also that it's parallel to the third side, which we did before, but let's prove it using similar triangles. Okay, so since this is on similarity, we are going to be looking at the lengths as ratio of the sides. So we probably need to know if the triangles are similar that are formed. So MN makes the triangle CMN, which I'm going to draw separately here. I'll draw it so you can see it. Here's CMN. I'm going to do it in red so you can see what I'm talking about. And then I have the bigger triangle CAB. So we are going to prove that the ratio of MN to AB is 1 to 2. And we're also going to prove that MN is parallel to AB. So here are my two triangles, CMN and CAB. All right. So let's go by what we're given. We're probably going to prove that these two triangles are similar so we can get the ratio correct. So we know in triangle ABC, M is the midpoint of AC and N is the midpoint of BC, and that's given. All right, so we're probably going to want to prove that the sides are parallel, or excuse me, that the triangles are similar so that we can prove that the ratio is 1 to 2. Sorry, got a little ahead of myself there. Okay, so what do we know if this is the midpoint? Well, what does that tell me about CM compared to CA? CM to CA right here. Well, won't that be in the ratio of 1 to 2 because this is a midpoint? This piece is half of this piece. So that tells me the ratio of CM to CA is a ratio of 1 to 2. And that's because of the midpoint. And also the same thing is true over here for CN and CB. So the ratio of CN to CB is also a ratio of 1 to 2 because midpoints divide segments in half. So if you're dividing in half, the pieces are a ratio of 1 to 2. So midpoints divide segments in half. So there we go. So we have proved that CM to CA and CN to CB are in the ratio of 1 to 2. So that means those two sides are in the same ratio. Now, we have two pairs of sides in the same ratio, so all we have to do is get an angle congruent that is between those two sides. Well, if we prove this is a ratio of 1 to 2, and this one is a ratio of 1 to 2, I'm just using X and Y just as an example because I don't know what the actual lengths are. What angle would we need to prove that the triangles are similar using side angle side similarity? Well, what about angle C? Yeah, angle C is the same angle in both triangles. Angle C is congruent to angle C by reflexive. And that means that triangle CMN is similar to triangle CAB by side angle side similarity. Those two triangles are similar. Now, if those two triangles are similar, what does that tell me about MN and AB? Well, that means that all the sides are going to have the same ratio. So if CM and CA are ratio 1 to 2, that means that MN and AB are going to be the ratio 1 to 2. So MN to AB is in the ratio of 1 to 2. Now, the reason for that is if triangles are similar, corresponding sides are in proportion. So there we go, they have the same ratio. Since we proved back here that CM to CA is 1 to 2 and CN to CB is 1 to 2, and the triangles are similar, MN to AB must also be 1 to 2. Now, we also want to prove that MN is parallel to AB. Well, what proves that lines are parallel? Well, angles do. We have alternate interior, corresponding, and interior angles at the same side of the transversal. All right, so looking at this, well, isn't CMN right here and CAB, aren't those corresponding angles? Yeah, they are. Are they congruent? Yeah, they are. Because what happens when triangles are similar? All corresponding angles are congruent. So that means angle CMN is congruent to angle CAB. Because if triangles are similar, corresponding angles are congruent. Now, corresponding here, I mean in the same place in the triangle. Corresponding angles are congruent. Okay, now since those corresponding angles are congruent, if we think of parallel line corresponding angles, they're in the same place in the parallel lines, here and here. So that means if those angles are congruent, that means that MN is parallel to AB. So, MN is parallel to AB. If corresponding angles are congruent, then lines are parallel. So we have just proved that if you have a midsegment, remember midsegment is created by two midpoints, it is parallel to the third side of the triangle, and it's also half the length of the third side. Now let's try a problem that deals with midsegments. In the diagram, P, Q, and R are midpoints of the sides of triangle ABC. So P is a midpoint, Q is a midpoint, R is a midpoint, and therefore PQ is a midsegment and PR is a midsegment. Now we want to find the perimeter of triangle ABC, so we have to figure out what X and Y is first. Okay, now let's think about what we know about midsegments. We know that the length of the midsegment is half the length of the side it's parallel to. So if we look at side PQ, it will be half the length of AB. So that means the ratio of PQ to AB is in the ratio of 1 to 2. Now, we also know that PR is a midsegment. It is parallel to BC. So that means the ratio of PR to BC will also be in a ratio of 1 to 2. So let's take a look at our values and see if we can figure out what X and Y are now. So we know PQ is Y plus 4, and AB is X squared plus Y. And that's in a ratio of 1 to 2. And then PR to BC, PR is Y plus 2. BC, all right, now remember this is a midpoint, so that means that BC, this is also going to be 3x minus 2, making BC 6x minus 4. Make sure you get the whole side there, is equal to a ratio of 1 to 2. All right, let's cross multiply. 2 times y plus 4, don't forget to distribute, is equal to 1 times x squared plus y, it's just x squared plus y. So 2y plus 8 is equal to x squared plus y. All right, I'm going to get my y's together, so I'm going to subtract the y here, so that gives me y plus 8 equals x squared. All right, now on this one over here, I'm going to cross multiply. 2 times y plus 2 is equal to 6x minus 4 times 1, which is just 6x minus 4. Distribute, you get 2y plus 4 equals 6x minus 4. Okay, so we have to solve one of these equations for either x or y. I'm going to solve this one for y because the numbers are smaller. So I'm going to subtract the 4, so that gives me 2y equals 6x minus 8. And I divide by 2, I get y is equal to 3x minus 4. So I'm going to use substitution. I'm going to take 3x minus 4 and plug it in over here. 3x minus 4 plus 8 is equal to x squared. So that gives me 3x plus 4 equals x squared. This is a quadratic equation, so I want to get it equal to 0, and I want the x squared to be positive. So I'm going to move these over here. That gives me x squared minus 3x minus 4 equals 0. Factor, factor, factor. All right, we know the signs are going to be plus and minus. The factors of 4 that give me negative 3 would have to be negative 4 and positive 1. Set them equal to 0. And x is equal to negative 1, and x is equal to 4. Now, can we use x equals negative 1? Actually, no, because if you plug it into this one, it'll give you negative 5, and that's not going to work, so we have to reject this one. Okay, so we reject that one, so x is equal to 4. All right, so now I can find y. 3 times 4 minus 4. 12 minus 4 is 8. All right, so we know x is 4 and y is 8. So now we want to find the perimeter. We've got to find the length of AB, AC, and BC. All right, so let's go through. AB will be x squared plus y. Well, 4 squared is 16 plus 8 will be 24. Y right here, y is 8. So this is 8 also because this is a midpoint, making AC 16. And then BC will be 6 times 4 is 24, minus 4 is 20. So here are my 3 sides. So my perimeter of ABC is equal to 16 plus 20 plus 24, which is equal to 60. So my perimeter of my triangle is 60. Now, what if we have a segment that intersects 2 sides of the triangle, but it's not the midpoint? Well, we have a theorem about that too. If a line parallel to one side of a triangle intersects the other 2 sides, not at the midpoints, then it forms 2 similar triangles, obviously, here and here. Okay? And it divides the intersected segments in proportion, but not the same proportions as the sides of similar triangles. So what's happening here is I'm going to create 2 similar triangles. Here and here are my 2 similar triangles, just outlining them here. If I take the ratio of these sides and I subtract out this piece, these 2 pieces right here, CP and PA, and CQ and QB will be in the same ratio, but a different ratio from what the ratio of the sides are. So that's an important thing. The sides are divided proportionally, and these 2 sides are in a ratio of their own as well. So keep that in mind when you're doing that. So whenever you draw a segment, it's going to divide the triangles into 2 similar triangles, but it also divides the sides in a different proportion as well. So let's take a look at applying this theorem. When we're dealing with similar triangles, it's very, very important to draw your triangles separately because it makes a difference when you're doing these problems. Okay, so I have these lines are parallel right here. That means I've created 2 similar triangles, and I'm going to draw them out separately here so we can see exactly what we have and what we need. So here are my similar triangles. Always, always, always draw your picture. So we want to find what x and y are. So we have our triangle LMN, and we have triangle LJK. That divides them into 2 similar triangles. Let's fill in our values. For the small triangle up here, this would be 6, this would be 8, and this would be x plus 5. Okay, now the larger triangle. What's the length of this side right here? It will be x plus 6. That's why you draw them out separately so you can see that's the whole side. Now, LK over here, add these together, you get x plus 11. So this side is going to be x plus 11, and JK is going to be y. All right, so let's find the value of x. Remember, when you do the sides of the triangles are similar, because of the parallel lines, it makes 2 similar triangles. The sides are in proportion, so we need a side that we know the ratio of. All right, so comparing our sides, what ratio do we have? All right, well, we need to figure out the ratio of. Let's do the ones that deal with the x's. All right, so we have LN, which is this side right here, will correspond to LK. There's 1 pair of sides. So LN is to LK. As I need another pair of sides. Let's do LM, this side right here. Those sides are in proportion. So LM is to LJ. Okay, fill in your values. LN is x plus 5. LK is x plus 11. LM is 6. And LJ is x plus 6. Okay, now we have to cross multiply here. Remember, x plus 5 times x plus 6 is a FOIL. And then you have to distribute as well. All right, so when you FOIL this out, it's x squared plus 6x plus 5x is actually plus 11x, and 5 times 6 is 30. I assume that you can FOIL yourself. You know how to do that. 6 times x plus 11 is 6x plus 66. Solve for x. You want to subtract these to get them over here. X squared plus 5x minus 36 is equal to 0. Factor, factor, factor. X plus 9, x minus 4 is equal to 0. 9 minus 4 is 36. 9 minus 4 is 5. Set them equal to 0. And x is equal to negative 9, and x is equal to 4. Whoops, positive 4. We have to reject this because we can't have a negative length. But x is equal to 4 would be the value of x. All right, so we know x is 4, See if we can find why. We'll finish the rest of the notes in class on the next class day.